United States could soon tap into energy from unexpected sources. The solar industry says there are more than 1 million individual solar panel installations nationwide, and the business could nearly double in size by year's end. But renewable energy accounted for only about 10% of the power this country used a year ago, which could mean it's a real missed opportunity. CBS News science and futurist contributor Michio Kaku is here to explain why. Good morning.
Good morning.
You know, it used to just be solar energy we were talking about, but alternative energy has really expanded here. And I know there's something to be very excited about, particularly regarding seawater.
Yes, this is straight out of Star Trek. For those people who follow science fiction, you know that fusion power is what drives the Enterprise and the Federation of Planets and stuff like that. But the French and the European Union, they're bidding the store on the ITER fusion reactor based in southern France. By 2020, they hope to turn it on, and by 2027, they hope to generate power. And the fuel eventually comes from seawater, hydrogen from seawater. It creates almost no nuclear waste to speak of, cannot melt down, but it's not ready yet. But we hope that within, again, a 10, 15-year time frame, we could be entering a fusion era.
So it's not just theoretical. This is going to happen at some point.
The Europeans have already spent over $10 billion building the ITER fusion reactor.
Wow.
It, of course, has cost overruns. It's been delayed. But when it's up and running, it could be a game changer. I mean, think about it. Almost energy for free. This is the dream of futurists.
Which actually brings me to this point. The United States is ranked number 8 when it comes to energy efficiency behind countries like Germany, Italy, Japan, France, the UK, and China. What's happening overseas that isn't happening here?
Well, first of all, Germany and Switzerland are even phasing out nuclear power, and even then, they're beginning to meet the energy needs of a growing economy. Energy efficiency, solar, wind power. Wind power is huge in Europe because, you see, Europe doesn't have the supply of oil that we have. We have gas guzzlers. We're addicted to oil. Oil's been cheap in this country, not in Europe. You go to Europe and you have sticker shock once you get that fuel bill, and you realize how expensive oil is in Japan and Europe. That's why they're gung-ho in wind power and solar power.
It's interesting, Facebook recently tested a drone that runs on solar power, right? How will that change, too? Because they want it to provide internet access around the world. How do you see that developing?
Well, you see, solar power is for free. You cannot meter the sun. And in developing nations where they have a hard time generating the power for the internet, why not have solar drones that simply get sunlight from the sky? And so that could be a game changer in the third world, making the internet almost for free and available for everyone from sunlight from the sky.
Wow.
What about Tesla's new battery?
That could also be a game changer. You realize, why don't we have the solar era? Every few years we talk about it, it never comes. The bottleneck is the battery. But this is where Tesla Motor comes in. They're now marketing a new battery, given the fact that prices have been dropping by 7% per year in the battery. Now, 100 years ago, Thomas Edison and Henry Ford had a bet. Would gasoline or the battery power the future? We all know that Henry Ford won the bet. But Edison may have the last laugh. Energy efficiency is now making the battery competitive with fossil fuel technology. Watch for it. The battery. People forget that. That's been the bottleneck for renewables, wind power, and solar power. When the sun don't shine and the winds don't blow, you're out of luck. Except that's where the battery comes in.
I wish I was as smart as you. Oh my goodness, so smart. Thank you for coming in.
Thank you.
Thank you.
Scientists have known of ice in the poles of Mars for years, but this week NASA confirmed the existence of flowing liquid salt water on the red planet. The moisture is still in trace amounts and often well below freezing, but its existence has huge ramifications for us humans. Could life be sustained on the red planet? Dr. Michio Kaku is here. He's a theoretical physicist, professor at the City College of New York, and certainly the smartest person who has ever sat at the oval plexiglass table. Welcome back, Doctor.
Well, glad to be here.
So let's talk about Mars. This is very exciting. What's the importance of flowing water, and why is that different from the frozen water?
Well, NASA hit the jackpot this week. The holy grail of planetary research is to find flowing liquid water, which can one day perhaps sustain life. To get life off the ground, what do you need? Three things. One, energy, like sunlight. Two, organic chemicals. Three, liquid water. Mars has two of the three, but Mars is frozen solid.
Yeah.
So how can life possibly exist? The key is in one word: antifreeze. You put antifreeze in your car so that it remains liquid even though everything else is freezing outside. That's why Mars has liquid water, because it has magnesium perchlorates, other chemicals which lower the freezing point of the liquid.
Okay, so these perchlorates that are in the water that allow it to still flow freely.
That's right.
Is there any way, I mean, you say that we could harness that for rocket fuel?
Eventually, the hope is that there are aquifers, underground aquifers that feed these little trickles of water, these riverbeds. Once we tap into the aquifers, we can get wells.
Yeah.
Once we have wells, we can refine it for drinking water. And rocket fuel. You can separate out the oxygen and the hydrogen, because water is H2O after all, for rocket fuel. And one day, maybe even irrigate crops. That, of course, is perhaps decades into the future. But the very fact that we can talk like this is amazing. The planet is frozen solid and yet has liquid water.
So has this moved the prospect of a manned mission to Mars forward? Is it closer than it was 2 weeks ago?
No, we're still talking about perhaps the 2030s.
Yeah.
We're still testing the booster rocket. We're testing the capsule. We're in the early stages, basically, of being able to send a manned mission to Mars. That's not going to change.
And
Matt Damon's going to have to wait.
He's gonna have to wait, but you know what? It's only what, 15, 20 years until we get there.
That's right.
All right. So those booster rockets, I've seen some interesting stuff from private space explorers. How important will they be? You know, because it doesn't seem like the government is going to alone be able to fund these manned missions. How important will private space exploration be to one day landing on Mars?
Well, everyone says, including the president, that we need a new Sputnik moment to energize the space program.
Yeah.
That's difficult because President Obama canceled Sputnik. He canceled the manned space program.
Yeah.
And he has left it to private industry to pick up the slack. So we don't have to thumb a ride on Russian booster rockets. So SpaceX, led by Elon Musk,
Yes.
is among the cutting edge of private enterprise getting involved in the space program.
Yeah, and he has designed some really interesting looking rockets that, you know, I don't know the mechanisms that actually make them fly, but it's certainly different than anything we've seen on Earth.
And that drives his space program. In fact, he wants to nuke Mars. You know that, right? I wouldn't go that far. We could do it. We could drop a hydrogen bomb.
But what does that do? Does that change the climate and warm it up for us?
That's the goal.
Yeah.
If we nuke the ice caps, liquid water will flow on the surface of Mars again, speeding up the terraforming of Mars. That is creating a Garden of Eden on the red planet. However, the fact that we have liquid salt water on Mars, I think, is a game changer. It means that perhaps we don't have to nuke Mars. Perhaps we just have to drill into the soil to get liquid water from wells.
Yeah, and then we can dig into middle Mars and create our own colony and little tiny Martian hobbits.
Who knows? I mean, the imagination goes wild, right, thinking about this.
Absolutely. I'm so glad you're back. Please visit us again. We can talk about the heavens, physics, and beyond. Dr. Michio Kaku, thank you.
40% of honeybee hives have died off in the past year. It's a trend that's been going on for several years. Could be devastating. Look at the chain. No bees, no pollination, no pollination, no plants means no life on Earth. A catastrophe. Here is theoretical physicist and author of The Future of the Mind, Michio Kaku. Is it that bad?
It's potentially bad. We are at the top of the food chain, and we forget the fact that it wouldn't take much to dislodge us from the top of the food chain. And pollination is at the bottom of the food chain. So many crops, so many vegetation depend upon insects for pollination.
So do we know what's causing this?
That's the killer. We don't know. We think that perhaps maybe it's pesticides, perhaps it's a virus that we haven't cataloged. There's no consensus in the scientific community.
But it's
so right
serious.
now, it's serious, but we're at a halt right now because we don't know where to apply our technology.
Somebody's going to blame global warming at some point, and I've not heard that yet, but I'm sure I will.
It could come up.
It will. But I want you to you're a physicist. I want you to give us the physics of a train going round a left curve at 106 miles an hour. Give me the physics of that.
Well, if you're a jet pilot, you know that when you bank on a turn like that, you have G-forces that push you into the chair, right? You can calculate that when this train went around that bend, the G-forces were such that the train tilted 10 to 20 degrees, enough to shove it right off the rails. There was no way the train could survive on the rails traveling at that velocity around that sharp turn.
Why was it going that fast? I mean, you probably don't know the answer, but it's astonishing.
Well, you know, we have common sense, which violates Newton's laws of motion. Common sense says that when you double the velocity, the G-force doubles, the energy doubles. Wrong. It turns out that if you double the velocity from 50 to 100, the G-forces go up by a factor of 4. Energy goes up by a factor of 4. In fact, that's why teenagers die so often in car accidents. They think that a fender bender at 30 miles an hour is nothing compared to a fender bender at 60 miles an hour because it's just double the velocity. No, it's 4 times the energy when you hit a car at 60 miles an hour. And that's why so many teenagers never make it after a collision at 60 miles an hour.
But what I'm reading between the lines here, if you have a super fast train, a bullet train, and it's going 200 miles an hour, for example, it can go around curves.
Except the radius of curvature has to be very, very large. Now, the radius of curvature of the bend was about 1,000, 2,000 feet. If you look at GPS pictures of the railroad track, from then you do the math. And you can calculate the G-forces are sufficient to push it right off the rail. However, in other trains, like bullet trains, their radius of curvature is much larger. It
has to be.
Very shallow curve, or else they're just going to fall off the rails.
What about this here's a new subject for you. There's an asteroid. I am told it's a mile wide.
About 1/8 the size of Mount Everest.
That's big.
That's big.
And it's coming within how many miles of the Earth tonight?
Well, today is the D hour because this object, one of the biggest in recent memory, is going to come whizzing by the planet Earth. If it hit the Earth, it could take out North America.
But it's not going to, is it?
It's not going to. It's going to miss us by 6 million miles, which is
close in space terms.
In cosmic terms, it's a whisker. It's just going to graze the Earth-Moon system.
Now, you can see this thing coming.
That's
Supposing
right.
we knew it was coming right at us. Is there anything we could do about it?
No, we are sitting ducks. We are powerless to do anything that is coming our way.
No, we could send up a nuke. We could send up a rocket, couldn't we? Get into outer space and blow it up before it arrives.
Nope, you cannot send Bruce Willis into outer space to intercept these things. Because, first of all, there's no space shuttle. It's been canceled. Second of all, the space shuttle just spins orbits around the Earth. The last time we left Earth orbit was when we went to the moon. And that was decades ago. We have no booster rocket. I repeat, no booster rocket capable of going into deep space to intercept an asteroid.
So what is the greater threat? The decline of the honeybee population or the possibility of an asteroid hitting us?
Well, it turns out that the honeybee thing is a direct threat. It can influence your dinner table today. However, the asteroid threat, no, these do come by, but on a scale of centuries to millennia. So I think that we can rest assured, but we need an insurance policy in case something does come by with our name on it.
Okay. Michio Kaku, always a pleasure. Thanks for being with us, sir.